And now.
There's like 3 there. Oh.
And now. Oh, cheap, crappy Wi-Fi adapter. How do I hate thee? Let me count the ways. No, let's not be impatient. And now. Now. Not bad. Not bad. Okay. Okay, so today we are going to look at going back through what we did in grade 9, 10, and 11 chemistry, talking about bonding, but now we're going to talk about knowing what orbitals actually. Does that make sense? Okay. So, who's excited?
No one.
I'm excited. Now, remember that in grade 11 you learned about the octet rule, and we said that a stable atom must have 8 electrons in its valence shell. And this is because we said that was stable. This fits with quantum theory, because if you remember when we looked at electron configurations, we said that full valence shells, what are the elements that have full valence shells naturally? The noble gases. And we said the noble gases occurred every time we got to a every time we have a full s and p orbital. And if you think about 2 electrons in each orbital, 1, 2, 3, 4, 5, 6, 7, 8. That's where the octet rule comes from. The octet rule says that an atom will be stable if it ends on a full s and p orbital. Is that logical? So the chemistry we did in grade 9 and 10, it dovetails nicely with what we're doing now. All right? So whatever shell we're in, doesn't matter. That's all I mean by N. Could be S, 1s, 2s, 3s, doesn't matter. If S is full and that same energy level's p orbital is full, if we have something that looks like this, well, then we've got a stable octet. A complete octet, because that's the language we usually use. We usually say that's a complete octet. So, taking a quick look at the periodic tables I still haven't given you, though hopefully one of you has there. Magnesium, how many electrons does it have in its valence shell, in its outer shell? How many? It has 2 electrons. If I was to draw a Lewis structure of magnesium, what would it look like? Yep. Yeah, you could do left or right, doesn't matter. I'm going to do right, but it's arbitrary. What would its electron configuration look like? What row is magnesium in the periodic table? What period?
What?
It's in the 3rd, which means its first shell is full. Its second shell is full. And its third shell, well, its third shell, what about 3s? What would it look like for magnesium? Just 2 electrons. And 3s is going to fill before anything will go in 3p, right? So 3p for it will just be empty. Cool. What about nitrogen? What can you tell me about nitrogen? Oh, Oh, I suppose I should say, what would its electron configuration be? I mean, I suppose I could write 1s2, 2s2, 2p6, but I don't want to write all that. When we write an electron configuration, what's the much easier way to write one?
Noble gas.
Find the noble gas and then subtract it.
Very good. What is the nearest noble gas for magnesium? It is neon. And what comes after neon's electron configuration here?
One other thing.
Yep, 3s. And how many electrons are in 3s? 2. There we go. That's not bad, is it? Does that feel comfortable for everyone? If I gave you that, you could do that. Let's do the same for nitrogen. How many electrons does nitrogen have in its valence shell? I can pull up the periodic table, I suppose. Or?
You should do like a split window so you have the table on one side and the rest is screwed on the other.
You know what? I will at various points where that will be useful. But yeah, you're right. If we look at, did I say I said nitrogen, right?
5, right?
I did say nitrogen, yes. So the answer is 5. If we look here, 1, 2, 3, 4, 5. Good. So it has 5 electrons in its outer shell. What then will its Lewis structure look like? Yeah.
I'm struggling to remember what nitrogen's.
It's not tricky. It's just N.
Oh, it's just N? Okay.
Yep.
And then 2 on the top, 1 on each of the other cardinal directions.
That's right. We just kind of go like this. And nice to have 2 on the top. There we go. Good use of cardinal. And what's its energy level diagram look like? Well, what period is it? Yeah, it's just in the second period. So that means it has a full 1s. And then what does its second valence look, or its valence shell, its second shell look like? How many electrons fit in 2s? And how many have to go into 2p? Which I should do like that.
No.
I think I should.
No.
I happen to be the teacher.
Oh, too bad.
All right. How should they go?
1 in each slot.
1 in each. Whose rule is that?
My rule.
Fun.
It's Vloot's rule. And we listen. Yeah, it's Hun's rule. And what is the electron configuration for this fine fella? Does it have a noble gas behind it?
The helium.
It is helium. Doesn't help us much. That's actually not much quicker than just writing 1s2. In fact, I think it's longer. But that's okay. What comes after that? Well, yes, but that shouldn't be immediately after. Yeah, 2s2 is after helium, and then so is 2p3. All right, why don't you guys take 1.3 minutes and do sulfur. Don't make it 1.4.
But it's so hard. It's so far down.
I can't see it.
It's not that bad.
Number 16.
Yeah, it's just there.
I'm going to miss for
I was going to ask.
What?
How we doing?
Where's sulfur? I'm blind.
Well, I'm here. I should do the whole thing where I type who's here and who's not.
You do it in 10 minutes.
Sometimes. On a good day. I'll have to edit this out of the recording. Hopefully it doesn't contain, like, important information. Like, Chris is absent because he's going to the bank and here's his account number, right? That'd be awkward.
Can't get much out, so go right ahead.
Was I talking to you guys about the time I accidentally just straight up typed my credit card number onto the screen? Well, yeah. Yeah, that was...
That was after Kyla found information about her.
Yeah.
I'm not here.
That may be true in spirit, but it is not true in... Yeah.
Not here. But
Okay, if somebody thinks they've got it and they want to come put it up here, that would be lovely. Or you can put your hand up and I could bring it to you.
can we go back to the table, please?
Yeah. No, sulfur. How's it going? Do you need anything here? Watch?
This is Kristen's phone.
Okay, just like, just this question.
She choked it up.
Oh, you got that. Oh, okay.
This is from her running.
I'm a little out of it. A little out of it. Okay. Oh, and actually, keep in mind that yeah, I got done.
So Derek cleaned out the score by myself with personal care.
You not know the electron configuration.
Sulfur. No, like what number? Because I see it out there. Unblocked.
Okay, what do we get? Talk to me.
I'm so sorry.
How many electrons in the outer shell? 6. Thank you. And, okay, so we look at sulfur. It has 6 electrons in its outer shell.
How's it? Minus 2.
No, you're great. And so it goes like that. And you can put the seconds kind of wherever you like. I'm going to set them up like that.
I didn't know if there's a special thing that like the up and down.
No, it's convention. All right, and obviously sulfur has a full first shell, which means 1s is going to be full. It's in the third, which means it also has a full.
2P's full.
2.
Yeah, 2s and 2s and 2p are full. And the third shell, how many electrons do we have to work with? So 3s is going to be full. That takes care of how many of those 6 electrons? 2. So what do I do after that?
3 has 4.
Sorry?
3 has 4.
Great, so how should they go in?
One on each, and then the second one goes in the first shell.
Excellent, like that. Okay, and how would we write its electron configuration? Yeah.
Me?
Yeah.
NE and then 3s2, 3p4.
Thank you. Could you please stop doing that?
Yes.
Thank you. I appreciate it. 3s2 and 3p4. Very good. Okay. So there we go. That's pretty good. The ability to do that, to get this information, is going to kind of be important as we think about this conceptually. So that's great. Now, ionic bonding. What happens when you form an ionic bond? Well, let's look at magnesium and nitrogen, and I want you to kind of divide your page in half. So let's look at magnesium and nitrogen. And the way we would always do this is I would draw magnesium. It has how many electrons in its outer shell? 2. Okay. And nitrogen has how many electrons? And I want to be colory.
Is that a word?
It is now. And I want nitrogen, and it has how many electrons in its outer shell? 5. Okay, stop right now. Thank you. Okay, so does this work cleanly as we see it here?
No.
No, of course not. Right? Because we can transfer an electron there, we can transfer an electron there, which is good.
But we need more.
But the problem is we need one more electron. Where are we going to get that? Yeah.
And another magnesium.
Very good. We're going to need another magnesium. And so we would draw a second magnesium. It has 2 more electrons, and it's going to give them both to nitrogen, right?
No.
What's the problem with that?
You have 2 many.
We can only give it 1.
That's right. So what do I need?
Another nitrogen.
Oh, boo. Okay. We need another nitrogen. And I'm done?
No.
No, because that doesn't help the fact that this nitrogen still needs 2 more electrons, so I would
Another magnesium.
another magnesium. Very good. And of course here we're going to be balanced, right?
Yeah.
This is where it actually does work. Great. That's very well done. That's the worst looking line anybody has ever drawn in the history of humanity and line drawing. That isn't much better, but I'm going to just leave it be. Okay. That is an old skill. We first did this in grade 9-ish. We talked about it. And we did it. And then we talked about it a lot in grade 10. We probably did it to death in grade 10. And then we did it again in grade 11. Right? Lots of practice. You know, I could have just said magnesium takes a charge of +2, nitrogen takes a charge of -3, and you could have just drawn it out and said, well, if I had one of it, right? Lots of ways to do that. But here's what I want to say. Let's look at the electrons, right? Let's look at the fact that magnesium is really, in terms of electrons, neon, but then it's got 2 extra electrons, right? Does that make sense? That's what those 2 valence electrons are. They're just extra. And how many magnesiums did we have? We had 3 of them, right? Just like that. So where are those electrons actually going? What does nitrogen look like? What's its electron configuration here? Oh, yeah. So neon again.
No.
Oh, I'm looking at the wrong one. So it is helium. It is helium, and then what does it have? And then what? 2p3?
Oh, yeah.
2p. Okay. So look here, we can see that these electrons go into that 3p orbital. These electrons are also going to that 3p orbital, but only one.
When does helium have 2s?
This is above helium. This is the electron configuration of nitrogen. So nitrogen's like a helium, but with 5 more electrons.
Oh.
Right? That's its shorthand notation. And the second nitrogen would look like this as well. And where is it going to get the rest of its electrons? It's going to get one of them from here. And then it's going to get those 2 there. Does that make sense? Is that comfortable? In other words, what is actually happening? What is actually happening is that these electrons are leaving a 3s orbital and going into a 2p orbital. Does that make sense? If you had wanted to, I don't want to, but you could have actually drawn the full energy level diagram for each of these, and you could have said that this electron right here is going to go to that orbital right there. Does that make sense? And then this electron right here is going to go to that orbital right there. Now, that would be drawing a lot of energy level diagrams. Do I want to draw that?
No.
God, I really don't.
What you want us to draw in grade 9?
But does it make sense that we can actually track not just what atom electrons are coming from and what atom they're going to, but we can actually say they're leaving this orbital and going to this other orbital? Is that fairly logical? Okay. Now then, for the purpose of today, I'm going to kind of stop talking about ionic compounds, because ionic compounds are pretty simple, aren't they? The electrons transfer, and they transfer until one of 2 things happens. You empty out the s and the p orbitals, or you fill them up. Is that really any different than what we've done in the past? No, not really. So we're going to leave it be. But we are going to go to covalent bonding. What does covalent bonding mean?
They share the E.
They share. So chlorine is pretty easy. What does chlorine's Lewis structure look like?
No.
How many electrons?
I'm yawning.
Did we do chlorine?
No.
No, but we can do chlorine. We're cool. Chlorine is also in here.
Oh, so that's
So there it is. So it's got 7 electrons. So,
You're tough, not us.
well, you're tough just by association. You hang out with tough people, keeps you tough.
Already tough, so by association, that means I'm tougher than you now.
That must be how that
Mr.
works.
Orlando, will you be adding the chemistry pack this out to the classroom if we're having trouble with this?
Yeah.
Does it associate with this course as well?
I have a separate one for this course that I'm working on. It's a little trickier to build, but that's okay. So in covalent bonding, what would happen?